Hi everyone, and welcome to our lesson today. Our lesson today is going to be about quadrilaterals. Okay, we're going to learn all about quadrilaterals and their properties. The three questions we're going to learn about today are: what is a quadrilateral? What type of quadrilaterals are there? And what are their properties? And how do we distinguish them from each other? Okay, as you can see, there's a lot of quadrilaterals around on this screen. So let's get straight to it and let's find out what they are. What is a quadrilateral? Now, a quadrilateral is any polygon with four sides. And because it has four sides, it also has four vertices and four angles. So remember, a polygon is anything that has more than three sides with straight lines and that's closed in, okay? So that would mean, let's try and draw a four-sided shape with straight lines, does it have four angles, four vertices, yes, and four sides. So this is considered a quadrilateral. I wonder what other quadrilaterals are there. So that's a rectangle. That's a very poorly done square. Let's use that as an example. That's also a quadrilateral. But I wonder if there's any other types of quadrilaterals that we could have. We could have a very poorly done parallelogram. As you can see, drawing is not my strength, but let's see how we go. And a very poorly done rhombus. We could also draw a trapezium, would also be a quadrilateral, and another quadrilateral you could draw, which would be something more like a kite shaped. A kite would also be considered quadrilateral. Anything that has four sides, four angles, and four vertices is a quadrilateral. Okay, but we've got to try to find, first of all, let's see, what do they look like? Now, I just showed you what they look like, but let's make sure we know the names of all of them. Okay, so let's start with the ones I don't have to draw by myself. Let's start with a square and a rectangle. The two most obvious quadrilaterals that there are. But if you were to take a square and you were to push a square to the side, so you can take the same sides there are now, like that, but you're going to push the sides like that. So now, hopefully, all four sides are still the same length. You've just pushed it over to the side. You've now made two acute angles and two obtuse angles here. So two acute angles and two obtuse angles. This is called a rhombus. Okay. Whereas if you took a rectangle and you were going to turn the rectangle to its side, once again, excuse the drawing, now you've got these two sides of the same length and these two sides of the same length. And now these angles in the opposite corner, they're now two acute angles, and the other two are obtuse angles. So basically, if you took a rectangle and you push it to the side, that's called a parallelogram. If for some reason I do make a spelling error in this, I am sorry. I apologize. I'm trying to do my best. So we have a square, a rectangle, a rhombus, and a parallelogram. Then we have the trapezium, which I went through, which has got four sides. These two are parallel, which we're going to get to in a sec, but the short side on the top is shorter. And then we have your kite, which is, so it looks like this, okay, in which these two angles are the same, but we're going to get to that. So these are the main quadrilaterals that you're going to see, okay? Rectangles, squares, parallelogram, rhombuses, and trapeziums and kites, if you want to put that in. Now, they're what they look like, so now we need to find out, how do we describe them? And there's a lot of different ways we can describe them, but some of the words we're going to talk about is whether all the sides are equal, okay, or some of the sides. Are the opposite sides equal? Are the opposite sides parallel? And we're going to get to parallel again before we start this. And then we're also going to describe the angles. Are all the angles equal? Or are the opposite angles equal? And we're going to go through this one at a time, but they're the things. So when you're properly describing the properties of a quadrilateral, you need to make sure you include all of these, otherwise it could be a different shape. If you want to say the opposite sides are the opposite angles are the same. Well, that's the case in a rhombus sometimes, and All right, don't mind the bell. Let's keep going. So sometimes we're going to describe the properties by sides and also by angles. Now, before we get into that, let's quickly talk about parallel lines. If you forget what parallel lines are probably not best drawn by me freehand because I'm not the best drawer. But if we took two lines like this, now that's the best parallel lines I can do on the spot. Parallel lines are two lines. Imagine these lines went all the way around the world. They went on forever and ever and ever. They are directly apart from each other and they stay the same distance apart the whole time. And if they were to keep going all the way across the world, they would never meet. They are parallel lines. Whereas sometimes you think lines are parallel, like this, but you can clearly see that the gap here towards the gap at the end is getting smaller. So if you were to keep drawing those lines poorly, like me, at some point, they would meet up. So these two lines are not parallel. Parallel lines are two lines that run alongside each other and they will never meet up as long as they keep going. That's going to be important to remember. Because now we're going to look at some of the properties, okay? So remembering, we're talking about sides and angles. Okay, they're the two main ways we describe properties of quadrilaterals. So let's take a square because it's the best one to draw without me having to draw it. Looks close enough, great. So let's use the thing about sides. In a square, all four sides are the exact same. So all four sides are equal. So you'd write down here, property of a square, all four sides are equal. And also, if we're talking about angles, we would say all angles are right angles. All angles are 90 degrees. So all angles are equal and all sides are equal. Let's take a rectangle. Now in a rectangle, we have opposite sides are equal. So let's use sides. So we're using that term opposite. So in a rectangle, and what about the angles? Well, in a rectangle, all the angles are equal. So that's how you differentiate between the square and the rectangle, is that all the angles are equal in both, but in this one, only the opposite sides are equal length, whereas in this one, all the sides are equal. Let's use that rhombus one that we were going to use before, which is where it's a square poorly drawn to bend over on the side. Let's have a look. Okay, let's have a look at the sides, the length. Now, if it's just a square pushed to the side, then the same thing applies here with sides. All of the sides are still equal length. So that would be the property. All sides are equal. But in this case, because we've pushed it, now we've made it so the opposite angles are equal. But not all the angles are equal now because we've got two equally obtuse angles and two equally acute angles. So you would write all sides are equal, opposite angles are equal. And that would be how you would know the difference between a rhombus and a square when you're talking about the properties. Okay, also one thing that you probably have seen before but don't always know is you'll see when I'm drawing, sometimes you'll see me do this. Those lines are to say that everything that has one line through it is equal. So if we were going to draw these lines here, and these angles are equal, so that will mean the ones with two are equal, the ones with two lines, and the ones with one are equal. Whereas these ones are all equal. Okay, let's use a parallelogram. Firstly, we could draw the same thing as we did before. Now, because we've drawn that, we can clearly see, because it's a rectangle side, once again, just like this one, the opposite sides are equal. Opposite sides are equal, the same as that one. But in this first one, in the rectangle, we said all the angles were equal. But because we've pushed it, we've now made it so that this angle is the same as this angle, acute angle, and these two obtuse ones are the same. So in this one, you would say opposite sides are equal and opposite angles are equal. Okay, we're nearly there. Let's try a trapezium. Now, I realize now we didn't do one thing. We should have talked about parallel lines. In the top one, 2 sets of parallel lines. These lines here are parallel, they'll never meet. And these lines here are parallel and they'll never meet. In this shape here, those 2 lines are parallel and those 2 lines are parallel. So we need to also write 2 sets of parallel lines. Now this is also confusing because it looks like it's going to be different, but it's not. In a parallelogram, because they're both pushed the same amount, those 2 lines are parallel and those 2 lines are parallel. So that's for 2 sets of parallel lines. Same as this one, the rhombus, 2 sets of parallel lines. So all the lines in these shapes are still parallel until we get to the trapezium. In the trapezium, let's look at the sides. Okay, ready? Is that side the same length as that side? No. But are those 2 ones the same length? Yes. So how would you write that? You'd have to write like opposite sides, 1 set of opposite sides are equal. All right, let's talk about angles. Are these 2 angles the same? Yes. Are these 2 angles the same? Yes, they are. So you've got opposite, but those opposite. Those aren't opposite. Okay. So although there are 2 sets of equal angles, they're not necessarily opposite angles that are equal. But let's quickly talk about parallel lines. We have 1 set of parallel lines here. Obviously, if I drew it better, it would be better. But these 2 lines are obviously not parallel because these, well, it says 1 set of parallel lines, but if these ones met pretty quickly, they would meet each other. So it has 1 set of parallel lines. So when we're looking at it, we can see a parallelogram has 2 pairs of equal sides, and the diagonally opposite angles are equal. Whereas with the trapezium, it just says 1 pair of parallel lines. Then we have all the other ones. We already went through all of these about what happens with equal sides and with the angles. So in your work, what I want you to focus on is describing, that's not a good color. Let's try that again. All right. Whether the angles are all equal, whether their opposites are equal, with your sides, once again, are they the same length? Not bad spelling. Are the opposites the same length? And I want to make sure you guys put in there number, once again, great writing, number of, nope, the number of parallel lines. Okay, so once again, if we go back to the start, let's go back, come on, keep going. So are all sides equal? Are the opposite sides equal? Are the opposite sides parallel? Remember, parallel lines are 2 lines that never meet. With the angles, are all the angles equal, or are the opposite angles equal, or some of them, nearly none of them are equal? So I hope this will help you with your activity about quadrilaterals. Okay, we'll put some more videos up as we go, but I hope this has helped. Thanks for watching.